Section 1, the method of science. Science is a way of learning about the natural world. Science includes all the knowledge gained by exploring the natural world and its way or process used to investigate what is happening around you. It can provide possible answers to your questions. Scientists use skills such as observing, inferring, predicting, classifying, and making models to learn more about the world. Every day, you think and act like a scientist. When a scientist tries to solve a problem, they know there are two ways they can solve it. One is a method of research that is descriptive in nature, and this is going to answer their question through observations. The other way is doing an experiment or an investigation which goes through steps of a scientific method. Different problems will require different scientific methods to solve them. Let's say you're out one night and you hear crickets chirping loudly. You think to yourself, I wonder if the crickets chirp more when the temperature is higher. This would be a hypothesis or an educated guess because this is something that you can test if you set up an experiment. In a controlled experiment, one factor or variable is changed at a time. This means that the variable controlled by you is called the independent variable. A dependent variable is the factor being measured. So in the case of the cricket chirps, the variable you will change is the temperature. The factor, or the dependent variable being measured, will be the number of chirps by the cricket. The variables that stay the same are called constants, and in this case, we would want to make the constants the same across each group of crickets. So for example, if you are measuring the chirps of 3 different groups of crickets, you would have the groups in all the same containers. All the containers would be in the same location, and all crickets will have the same amount of food and water. These are the constants that will stay the same in each group. So we know that these do not affect the chirps of the cricket. Your experiment will not be valid unless a control is used, and a control is a sample that is treated like the other experimental groups, except the independent variable is not applied to it. So in this case of the crickets, the control group would be the group in the regular air temperature. Experiments are essential to scientists because those with testable hypotheses help scientists develop theories based on their observations or the world around them. When scientists use experiments to develop a theory, they use their observations to notice patterns or similarities in the outcome of an experiment. A scientific theory is different from scientific law in that laws are summaries of a wide range of observations as a result of the experiments. The theories, on the other hand, are explanations for why these observations and results occur. So in general, laws describe what happened and theories explain why things happened. So for example, the black hole theory explains that black holes are points in space that are so dense that they create deep gravity sinks. And these gravity sinks beyond a specific region are so strong, not even light can escape this powerful tug. So anything that gets too close to the black hole, whether it be a star, a planet, or even a spacecraft, will be stretched and compressed like Play-Doh in a theoretical process known as spaghettification. This black hole theory can be explained by using the universal law of gravitation, in which all objects attract each other with a force of gravitational attraction. Gravity extends beyond Earth and is universal, and this law states that this gravitational attraction is directly dependent upon the masses of both objects.